Hi everybody, it's Mrs. Dr. B. Friday we went through an entire process where we first used the table that's right here, and we went through the periodic table, the SPDF periodic table, and we just simply put tally marks in here, and we did that for gallium. The other three elements on that same sheet of paper were potassium, silver, and barium. I'm not going to do potassium or barium. These are for you guys to do. And I'd like for you to go ahead and start with those when you're ready to. If you weren't here Friday, then I would love for you to watch this video. If you feel like you need a refresher because you want to just remind yourself what we were doing, then again, watch the video. It's not required. Obviously, if you're watching it right now, it may be because you want to. But electron configuration is not difficult. It is a process. And if you know this periodic table, and you do what I say to do, which is to let your fingers do the walking, just like when you were learning how to read, you started in the upper left-hand corner and you just basically went across. Again, it was Dick and Jane played with Spot, or at least that's what it was when I was growing up. And so you go to the first row, and then after that you go to the second. Let's go ahead and mark these and remember that this number over here to the left, which is 1 through 7, represents the valence shell. All right? Now we call it the energy level, and the energy level on the outside is the valence shell. So when you are on row 4 of the periodic table, it means you have 4 energy levels, and the outermost one is energy level 4. That does not mean every electron placed on this row goes into the 4th energy level. That's not true, because we have these guys in the middle, and those are 3Ds. And I know this is small for the video, but those of you in class have already done this, and we understand that the Ds, which is the center section, and the F section are never on the outside. They're never valence electrons. And that has to do with electron stability and the ability of the atom. This is just an easier way of thinking about it. It may not be perfectly good chemically, but it's the atom can't hang on to those if we have that many out there. The analogy I used in class on Friday was the pioneers going across the country. They traveled in their Conestoga wagons, and whenever they found any kind of danger or they sensed that they were possibly in danger, they would circle their wagons. If there were 13 or 14 wagons and only 8 families, they would never put all the wagons on the outside. Why? Because they could not fully defend and hang on to and take care of everything. So they put things to the inside. And that's the same thing that the atom does. All right? So that's just the background here. We've used this. We already calculated the math for Aufbau. So regardless of which method you use, you need to know that Aufbau says 1s, 2s, 3s, 2p, 3s. And this order is the exact same order that your periodic table tells you to use. So if you know this or this, you will not or should not make mistakes with electron configuration. All right? It is not a difficult process. Breathe. I believe you can do this. All right? So what we're going to do is we're going to do silver. So the first thing you do whenever you do an electron configuration is find the element. And silver is right down here. It is element number 47. That means we have to have 47 electrons, and we do not finish until we have accounted for all 47. So let's start the way we started on Friday. We're going to start all the way up at the beginning, and that's hydrogen. And we see that this is a 1s, and I'm not going to do this one at a time, but you can see we have hydrogen and helium. And I'm just going to put a check mark here simply so that we can go through them. And so we have 2 electrons placed in the 1s. So what I'm going to do is I'm just going to put 2 tally marks. Now eventually we'll have to turn those into arrows, but that's when we're doing the Aufbau diagram. Right now we're not worried about that. We're just trying to make sure we get 47. Right? When we're done with the first row, guess what? We have to come to the second row. And we have lithium and beryllium, and those are the 2 S's. So guess what? Since we have to do both of those to get down to 47, let's put check marks and let's move on. Next up is the 2 P's. All right, remember we have 3 different orbitals or suborbitals. Each one can contain 2 electrons, and we're going to go boron, carbon, nitrogen, Hund's rule, oxygen, fluorine, neon. And so we are now up to 10 electrons. All right, moving on, we have to, once we're done with this row, we have to go to row 3. We are now on the 3rd shell as the valence electrons. Sodium and magnesium, elements 11 and 12, are in our 3 S's. Going straight across this empty space, we get to elements 13 through 18, which are the 3 P's. And so again, we do aluminum, silicon, phosphorus, sulfur, chlorine, and argon. And when we get these, argon is element number 18. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're good. Now we all know from the Aufbau diagram that there's also 3 D's. So since we just finished with the 3 P's, we would think, well, maybe we have to do the 3 D's. But the periodic table and Aufbau both say that before the 3 D's, we have to have the 4 S's. Look here, it says 3P, 4S, and then we make it around to the 3 D's. That's the same thing the periodic table says, because when we get finished with this 3rd row, guess what? We have to start the 4th row. And the 4th row starts with the 4 S's, potassium and calcium. Let's go ahead, put those electrons in there, and then look at, we're to the 3 D's. And so we have 5 boxes here. This entire section is a 10-block section. So the first half of it is always filling each one of these boxes with the first electron. So we're going to go scandium, titanium, vanadium, chromium, and manganese. Now, if you were taking AP chemistry with me, we would find out that there's some variation and some exceptions in here as to how this works. We're not in AP chemistry. We don't worry about that. We just put 1 in each box, and then we take the second half, iron, cobalt, nickel, copper, and zinc, and we put in the second electron. We don't care about the exceptions. We just care to fill the block of electrons, okay? All right, so we are on element number 30. We have to get down to 47. We still got a ways to go. So how about here? We'll go over here to the 4 P's. We again have our 3 gallium, which we've already done, germanium, arsenic, selenium, bromium, krypton. And guess what? We're on 36. Now, when we get down here, you can look here. We're now finally on row 5. That means our valence electrons are going to be in the 5th energy level. We're not going to finish. Look, there's silver right there. So we understand that at this moment, somewhere along this, we're going to be done, right? So here we go with 37 and 38, rubidium and strontium. And then let's move in here to the 4 D's. Yttrium, zirconium, niobium, molybdenum, tactinium. Let's get those done. 1, 2, 3, 4, 5. All right, after that we have rhodium, and then we have palladium, and then we have silver. Oh, excuse me, I forgot about ruthenium. Ruthenium, rhodium, palladium, and then silver. All right, so guess what? We're going to put a 1, a 2, a 3, and a 4. The last one, which is cadmium, we're not going to do anything with, because guess what? That would be electron number 48. So just to double check, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. This is at the end of our fourth row. All right, so then we have 38, 40, 42, 44, 46, and one more is 47. So here is our, this is what we referred to officially as an orbital notation. And again, with a little bit of additions there. But what we want to do is just make sure we understand where they are. And remember, we let our fingers walk through here. It told us specifically, because we already have this here, where the electrons are being placed into the atomic, electron cloud. All right, so let's take this one off, and let's move ourselves over to creating an electron model. That's the next thing you're going to be doing. You are not required to fill in this table. If you can use this periodic table to complete your electron cloud, you're fine. And that's perfectly fine. You don't ever have to do this. This is just another resource you can use. All right. So what are we going to do? Well, we are going to remember this is the order. This is what we're filling out. Remember, 1S's. And if you will remember the way we do this in this classroom, all of our S's go up here. This is that S column. I'm going to call this my PX. This is going to be my PY. And this is going to be my PZ. This is each one of these three boxes. I like to say PX is first, then PY, then PZ. Let me see if I can make this. If I make it purple, if it's a little bit darker for us, there's P sub X, P sub Y, and P sub Z. I think that's a little bit darker. So let's fill this out. We've already got this. So how about let's fill out the first two S's. So what you're going to do, I'm going to count. You would circle this in. Here's 1 and 2. All right, first two electrons. And what I'm going to do is I'm going to cross them off. All right, there's no more electrons on this diagram. Remember, the diagram is, the template is only our valence electrons. S's and P's are the only ones on the outside. All right, so once the first energy level is filled, where do we go? Well, we go to the two S's. So here is our third and fourth electrons. Again, you'll just fill them in with, just fill in the circles. And what comes next is our two P's. Well, we do this one, which is 5, 6, and 7. Remember Hund's rule. 8, 9, 10. And our first and our second rows are filled. Let's go to our third row. 11 and 12. That would be sodium and magnesium. Let's go to our three P's as we go across the periodic table. If you need to see the periodic table again, here we are with sodium and magnesium, and we're moving our way over to aluminum through argon. So aluminum, silicon, oopsie, almost put in the wrong spot. Phosphorus, I'm getting ready to write the element instead of the number. Phosphorus, sulfur, chlorine, and argon. Okay, and now look, the third valence shell is full. The third valence shell is full, which is what we see there. All right, which means we have to go to the fourth energy level. And there we're going to have potassium and calcium, which is 19 and 20. And guess what, guys? 19 and 20 right there. There they are. But now we have to do these guys, and these are the 3Ds, which means I have to go inside of the fourth circle. This is the fourth circle. This is my valence shell right now. I have to go inside of that to be able to put these. Now what I did on Friday, and I'm going to do again here, is we know we have 10 boxes. The template is only for valence electrons. So what I'm going to do is I'm going to put, or we have 10 boxes across here. We have 5 different suborbitals. So what I'm going to do is I'm going to put 1, 2, because they're coming in pairs, 3, 4, 5, 6, 7, 8, 9, 10. Now each one of those goes into one of these boxes. So an electron here goes in some place, electron here goes in some place. Obviously these two will go together in this structure here. 5 different suborbitals, orientations of the 3Ds. All right. So we are at 19 and 20. Oops, sorry, I forgot to close that off of there. All right, there's 19 and 20. So what we want to do is we want to go, because this is 21 through 30. So let's put them in here. All right, so here goes, let's see if I can do this with, if I've got a blue that will work. 21. 22. 23. 24. And 25. So that's the first one in each of those. 26, 27, 28, 29, and 30. And I did them in a different color, tried to put them in there. So guess what? You can see how they are inside. There's the fourth energy level, again, the valence shell, but these were put into the third energy level. So there's your first D box, your second D box, third, fourth, fifth. And each one of those D's, remember, is the D suborbital. We call it the daisy. There are 5 different orientations to make sure that it's 3-dimensional, but each one of these is a different one of those 5 right here. Okay, so guess what, guys? We are in element number 30. Where do we have to get? 47. All right, so let's continue on. After we do this, we now know the next thing that it says we do is 4Ps. Look here. There, we're done with these guys. We're right here to the 4Ps, which is gallium through krypton. Trying to get this done as fast as we can. Let's go back to doing this. We got 30. We have 31, 32, 33, 34, 35, 36, and we're at the end of the 4s. Where are we now? We're at the 5s. So we've got 36, 37, and 38. And now my job, which is through strontium, is to come back in, and again, we are now here. And these are the 4Ds. So I'm going to do the same thing. I'm going to do it a little bit different. I'm going to go ahead and put the big box with 2 electrons per box You don't have to make them squares. You can just make them circles. I'm just doing it this way so that you can see that they are not valence electrons. The only ones that are valence electrons are circles. That's the only reason why I'm doing it this way. Just need you to be able to try to see that they're a little bit different. All right? So let's go ahead. We're at 38, 39, 40, 41, 42, 43. That gets to technetium. All right? 43. I almost forgot what count my is. 44, 45, 46, 47. So we are where we need to be. I need you to notice that spot on that D orbital is open. That means this one electron is unpaired. He does not have a pair of another electron that's paired inside of here with him. All right? But this is what it looks like. All right? This is what the atomic structure looks like. Your question from me would be, how many valence electrons are there? All right, how many valence electrons? So what do? You come up here on the S's. It's the easiest thing to do is look. I got 1s, I got 2s, I got 3 S's, I got 4 S's, I got 5 S's. All right, I don't have 6 S's, which means 5 S's. My valence shell is going to be the 5th shell. And guess what? I only have 2 electrons here. So I would have 2 valence electrons. If you look at this drawing, you're going to look for the electrons that have the largest coefficient, the number in front of the letter. That's a 5. And how many do you have? You have 2 of them. All right, so we're going on 25 minutes. We're going to try to get this finished as quickly as possible. All right, so guys, we first did this by walking through the periodic table. You could do this one through walking periodic table. Also, the problem with this is putting those D's in. Putting the D's in makes this a really tough drawing sometimes. Hopefully this helped. What's really cool about the Aufbau drawing is that you can't mess this one up, because Aufbau is the filling up. He says you have to put the electrons in the lowest energy level possible. All right? We start at the bottom, that's the lowest. And you can see you're zigzagging on your way up. But as long as you follow the zigzag, you should make it, and it should work. We've got this one, which tells us the order. This one, which tells us the location. And now what we're going to just do is put in the electrons. We can go back and do this again. The only thing we do different with this one is one of my tally marks is going to be an upward arrow. The other one inside is going to be a downward arrow. We'll talk more about this when we get to quantum numbers in a week or so. So there's 1, 2, 3, 4. I'm not even going to worry about this. I'm just going to start counting. I got to get up to 47. There's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Here comes our 3 Ds after our 20. 21, 22, 23, 24, 25. Sorry for being left-handed. 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36. End of the fourth row is element number 36. 37, 38. 39, 40, 41, 42, 43, 44, 45, 46, 47. Look here, I got 5 boxes in the 4Ds. 5 boxes in the 4Ds, all of them except for the last one has a single. Are paired, this one is single. Right? So again, you're going to look here. You're going to say, what's the biggest number? It's element. We're in the period 5 elements. That means we know we have our valence electrons are in the 5s, and we only have 2 5 electrons in here. All right, final thing. And that has to do with this very last number that we're getting ready to put in here as we do electron configuration. When you look at the very last placement of the very last electron, it's not here. This is not the last electron. This is the last electron. It's the 9th electron in the 4Ds. All right, it's the 9th electron in the 4Ds. So what we only have to do now is very quickly summarize this, or this, or this. This is the easiest one to summarize. So what I'm going to do with my left-handedness is I'm going to write it up here so that you can see this. We're not doing these. I want us to write it up here so you can see it. So the first thing we're going to do is this. We're just going to start writing. I'm going to use the purple because it seems to be the best one. Actually, the blue works really well. All right, where are we starting? We're starting with 1S's. 1S2. We have 2 of them. We have 2S. We then come up to the 2P's. And there's 6. 3S. There are 2. 3P. There are 6. 4S. There are 2. 3Ds. There are 10. 4Ps. There are 6. 5S. There are 2. 4D. There are 9. When you add all of these up, 2, 4, 6 is 10, 2, 4, 6 is 20, 30, 36, 38, and 9 is 47. We know we've got it right. Now, this is what I want you to get to, the very last thing we have to do. You can identify who this is. This very long thing, this thing, this thing, even if you didn't know we were looking for silver, simply by taking back this periodic table and saying, okay, I got to go to the 4Ds. Where are the 4Ds? They're right here. I got to get to the 9th one. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's silver. This number, this address on the periodic, on this electron configuration is silver. All right? So I'm a lot longer than I wanted to be. For those of you who had to watch the whole thing, you're not going to get a lot done during class. But guys, I just needed you to be able to see this again. Thanks for watching. Have a great day. See you Tuesday.